It's too far away. All right, so last time I think we did the probability formula for a binomial probability. What the hell does binomial probability mean? What does that binomial mean? Bicycle. Two options, two possibilities, right? So you can basically make anything in the world too. Is rolling a die, does that have two options? You might think no, but yeah, sure it does. 5 or not a 5. There, I made it two options. So any situation where you can make probability of something and the probability of the opposite of that thing, you can set it up as a binomial situation. I like it. So I can roll a die 8 times and say, what's the probability I get 6 5s? So my probability of success would be getting a 5, and my probability of failure would be not getting a 5. Do you see that? So you can almost make everything binomial if it's set up correctly. So let's just remember what we did last time, since it's been a little while. The formula we came up with for the probability of some number of successes. So let's see, if I have n total things, we call them trials. So there's a question in the homework that deals with, you have 32 questions, and there's 3 choices in each question. So 32 would be n. I'm doing 32 of the same thing, a question, and then another question, 32 times. And if there's 3 choices, what's the probability I get a question right? There's 3, A, B, C. And how many right answers are there? Probably 1. So what's the chance I get a question right if there's 3 choices for each question? 1 out of 3. So P would be 1/3. And so forth. So that's the first thing you want to do, is take the situation they give you. What's N? What's P? The minute you know P, you know Q. Because what's got to be true about P and Q? Oh shit, who remembers? So N is the total trials. P is the probability of success. Q is the probability of failure. X is the number of successes. Cool. So what's got to be true about P and Q? They're opposites, so they have to add to be 1. I like it. So if you know P, Q is 1 minus P. You get it right, Jeff? So if you know P, the probability of success is 1/3, what's the probability of failure? The rest. What would that be? 2/3. I like it. So that's why when we did the binomial PDF on the calculator, do you remember that? We only had to tell the calculator N, P, and X. Because if we tell it P, it should be able to figure out Q on its own. It's a little calculator is what it does. All right, maybe. So let's try a problem out. Just remember, and the formula looks like this. This was the part we had to kind of come up with a way to do it. I talked a little bit about factorials, because if you do that by hand, it's got these exclamation marks in it. But I can just do that on the calculator. It's one place where I'm like, it's not worth it to do that. Just let the calculator count how big the list would be. All right, I like it. So let's try a problem out, because these problems, I desperately want you to see how the problem tries to set the equation up on its own. And then we'll do some more difficult problems. So if I said, let's see. So let's do like we just did. Let's say I had a 20 question quiz. Each question has 4 options. So they got A, B, C, D options, right? In some other class where they let you take a Scantron in. Not my class. So what do I already know just from this? All right, so what does that relate to? So N is 20. So each of those 20 things is a question. For a single question, what's the probability of success?
1 out of 4.
1 out of 4, I like it. So P is 1/4. Therefore Q, 3/4. I like it. Or, you can make it 0.25, 0.75. How are we doing so far? So this is the big thing with these. In fact, most statistics really is like this. You take the situation you're given and you try to figure out the numbers in that situation relate to what in my equations, right? You're trying to relate them to the variables. So it's not true word problems. I know these problems have a lot of words in them. That doesn't make it a word problem. A word problem is where you have to come up with your own equation. We just have to figure out what do I plug in where into the equations, right? That's a totally different, easier problem than a real word problem. I know you guys don't totally believe me, but oh well. And now I can't say anything else until I ask the question, because X is the number of successes. I don't know. So let's say, what's the probability I get exactly 7 correct? How would I set that up? So how many questions are there? 20. And you want to choose how many to get right? 7. So how many of these do you want?
7.
7, because that's successes, right? I want 7 successes. So how many failures do you want? 13. Let me stop there for a second. You guys see how that set itself up? I got 20 questions. I want to choose 7. How did I know that? Because they told me I want 7 right. So I want to choose 7 to be right. So how many do you want right? 7. And how many do you want wrong then? 13. I like it. I know that sounds weird to say you want 13 questions wrong, but to answer the question, you want 13 questions wrong to get exactly 7 right. How are we doing? Semi good? We'll do another example. Don't freak out. And now, can you put that into your calculator? If you have your calculator. If you don't have your calculator, get near somebody with one. All right. Sorry here. All right. So let me remind you guys.
7 power, and then 0.75 to 13 power.
First thing I want to remind you guys is here under Math 160 on the website, TI Calculator Guide, and it's just empty. Oh, there we go. And then down here, distributions for a binomial distribution. It tells you about binomial PDF, right? This is the shorthand way of doing it. And then last time I gave you guys a handout that shows you the way to do it officially, right? So in the Calculator Bible, in the Calculator Guide, Bible, it'll tell you the shorthand way to do it, right? This is the quick way to do it, just to make sure it came out right. And on the handout I gave out last time, I don't know if I have any more with me. Yeah, cool. I got a couple. Anybody need that handout? Okay. Got it. So that explains how to put that in the calculator. So, if I wanted to put that in the calculator, it would look like this, 20. How do I get to choose? Good, math. Probability. Number 3. 20 choose 7 times 7 of these. There's your to the button right there, right? That's your to the button. times 0.75 to the rest. I put 1 parentheses 1 not. Oh well, I don't need. So is that what you get? 0.1124? So like just above 11% chance, if you randomly guess on this quiz, that you'll get exactly 7 of them right. Yes, sir?
So that won't be a 13 and not a 1. Because you wrote 1 over there. Confused. On the bottom.
Oh, I think it got erased. My bad. Over there is 13. I erased the poor little 3 dude. Yeah. So what's always got to be true about these two?
You gotta add it to the total.
They got to add it to the total because I'm breaking the group down into 2 distinct groups. You can always do that. People that think you can and people that think you can't. There, I just did it. Haha. Right? Well, you can break it down into success. In this case, the success makes sense because the success would be getting it right, and failure, which is getting it wrong. And in general, success doesn't have to be a happy thing. Like I said before, it could be a rabbit, squirrel, or a dead body. It depends on what you're looking for. And then to do this shortcut real quick, you go to distributions and go to binomial. Do you remember the difference between these two?
Particular.
Good. P is particular, so that's when I want exactly something. And that's the problem I've got. And C is cumulative. If I want to know at most 7, so it's from 0 to 7, right? So if I want particular, I can do that one. And then I tell the calculator N, which was 20 questions, right? Yeah. P, which was 0.25, and X, which is 7, and I should get the exact same number. Thank God. Because all the calculator does is it does that equation, right?
How do you get that again?
You go to distributions, right here, above vars, second vars, and then you go to binomial, which is down here. Yeah. Again, that's just to check your work. This would be your work, setting up the equation. So what I love is when the equation's wrong and then the right answer shows up. I'm like, oh shit. All right. So I don't know what the hell you did after this, but the equation better be set up right, or else that's bad. It's a bad sign.
So how do you change it to get at least 7?
I like it. So, by hand would suck so bad. So there are a few in the homework that make you do this, but can you help me figure out if? So this is number 1. If number 2 said the probability that it's so what was it 0.1124 or something? The probability that X is at most 7. So how many ways is there to get at most 7 right? Give me one way to get at most 7 right. You can get 7 right. Or what? 9 is not at most 7.
6, right?
7, 6, 5, 4, 3. So I can do 7, which you already did, or 6 right, or 5 right, or 4 right. Oh shit. Now, the homework they ask you to do, that looks like a lot of work, but in the homework, the one problem I'm thinking about, very quickly, these probabilities become 0. Right? If I ask you, what do you think the answer would be, the probability that if you guessed on each of these questions that you're going to get more than 18 right out of 20? What do you think that probability is going to essentially be?
0.
It would have to come out to be freaking 0, right? So when you do probably 18, it'll basically 0, and then probably 19, and you're like, I don't have to do anymore, right? And the answer is going to be freaking 0. How are we doing? What's the most likely number of questions that a person would get right?
1.
So what percentage of them do you think, what's the probability somebody gets a question right?
50?
25%, right? We know that from the beginning.
Oh.
There were 4 probabilities. There were A, B, C, D, E. So what's the probability you get the right one? 1 out of 4, 25%. And how many total questions are there? 20. So then I would take 25% of 20. So one little thing we haven't officially done yet is, but I did point this out, we got to finish that handout from last time. The mean for NPQ problems, what I call them, binomial probabilities, I call them NPQ problems. Hopefully that makes sense. The mean is going to be n times p. Now, please, dear God, let that make sense. If 25% of the time I'm going to get a question right, and you give me 20 questions, how many questions am I going to get right on average? 25% of 20. Does that just make common sense? Does that make sense? That's what this equation says, isn't it? It says percentage of the number. So in this case, it would be 20 times 0.25, which is
5.
5. I like it. Cool. Now, to be honest, this won't actually always be the highest probability necessarily, because the highest probability would be the tallest bar. Let me see if you guys are with me. Can you imagine I could figure out the probability for 0, the probability for 1, the probability for 2, and so forth? And I can make this I can make little rectangles that represent those probabilities, right? So the mean would be 5, but the mode doesn't have to be 5. It could be close to 5, right? But most of the time it's going to be this. This should be the highest probability most of the time. It's a very small subset of times it won't be this. So if I did this, what's the probability that x equals 5? How would that compare to this? It would be higher, because that's the average. That's what I expect it to be around 5. So 5 should be higher probability than 7. I like it. So try to do that. Figure out what the probability that it's exactly 5. And I think that catches us up, and I want to finish this handout from last time. Yeah, so 20, choose 5. So I want 5 of these. So how many failures do I want? 15. Cool. I like it. You gotta love that formula. You really almost have to. If you're forced to pick a formula to love, that should be the one you should love, because it just sets itself up. 20 questions. Choose 5 of them to be good. Okay, 5 of them are good. The rest of them are bad. There you go. That's how all of those always set up. As long as you identify NP and so forth correctly, that should be an easy question. And what'd you get? Sorry, Dean?
0.2023.
2023. So 20%, definitely higher than 11%. So if I just randomly guess, I would expect to get around 5. It's the highest. It should be around the highest probability. All right, let me stop there for a second. 2023. Cool, I like it. Okay, so let's go back to this. Hopefully everybody has one of these now, because this is the last one I have.
Real quick, I'm sorry.
Yes?
Can you do the binomial one again? How you put it in the calculator?
Yeah.
Sorry.
So let me do both. Let me do, to put that last one we just did in like this. 20, choose 5, 25 to the 5th, 0.75 to the 15th. Bam. So that's 2023. Yeah, I like it. And the shortcut way would be go to second vars, go to distributions, and the first couple are related to the normal curve somehow, right? You go up, because it's way down here at the bottom, binomial PDF, and then in there I would put there's 20 questions, 25% chance of success on any one of them, and then I want to get 5 of them right. Bam. Same exact probability. Because the calculator, again, it just does that formula. Alright. I think, did I do one like that? Yeah, sort of I did. Let me do one more up here on the board before we go back to this. Because I do want to do one like this. If I said, what's the probability that I got at most 3 right? I would have to do the probability of what? At most 3 would be what? How can I meet that? I can get how many right? 3, 2, 1, or 0. Right? So I would have to do 20, choose 3. 0.25 to the third, 0.75 to the rest. Are you guys, that's probably 3, right?
Yeah.
0.25 to the third, so 0.75 to the what?
17.
17. I love it. If there's 3 successes, there must be the rest failures. So that's one way to do it. Or 20 choose 2, 0.25 squared, 0.75 to the 18. I think you guys get the idea, right? So that would probably be the most I would make you do is like 4 of those bad boys, and then it just starts to get to be busy work. Are you guys with me a little bit? A little tiny bit? All right, all right. Let's see if we can't do this real quick. First, 0.75 to the 19th, and then finally, 20 choose none, so no successes, all failures. All right, let me stop there for a second. So let me do this 2 ways. I'm going to do this straight up, and then I'm going to do it. Now what do I want to use? Do I want to use binomial PDF or binomial CDF? CDF, probably the way I said it gave it away a little bit. But I want it most 3, and binomial CDF does 0 up to the number you put in. So if I want it most 9, I would put the number 9 in, and it would do from 0 up to 9. It would add all those probabilities together. C stands for cumulative. So if I just do it directly, here's the nice thing about this is I've already got that in there, so I can just change this to 20 choose 3. 5 to the third, 75 to the 17, no, not 157. So that's that first piece, right? 20 choose 3, 0.25 to the third, 0.75 to the 17th. Okay, and then I can do, so if I hit second enter, it brings up the last thing that was on the screen. Or I think if you got the newer ones, you can just hit the up arrow and it goes to the ones previous. They don't have a scroll bar yet on these TIs. So then I can change that to 2. You guys see what I'm doing? Just to make it quicker, I'll put the whole thing in there again. 18. So let me keep track of this. So that was 0.1338, right? This is 0.0669. This will be, let's see. .0211, and this is, let me ask you this real quick. How many ways is there to choose nobody from 20 people? If I choose one person from 20 people, I can pick the first person or the second person. There's 20 ways to do it. If I have 20 people, how many ways can I choose none of them? 1 way. I go, I choose none of you. There's only 1 way to do it, right? All right, mathematically. I mean, there's a lot of, I don't choose any of you. There's a lot of different ways to say that. There's only 1 way to choose none. I don't choose any of them, right? So that's 1. What's anything to the 0 power? 1. So then the whole thing is 0.75 to the 20th. That's all I have to put in there. If you don't understand it, just put the whole damn thing in. But the first pieces come out to be 1. There's only 1 way to do this, and anything to the 0 power is 1. So 0.75 to the 20th. 0032. If I add all those up, what do I get? I don't know. Let's see. Plus 0.0211 plus 0.0669 plus 0.1339. You get 2251 roughly. All right, now let's check that. Let's do binomial. Now I want to do CDF because I want to go from 0 up to 3. I'll let you guys catch up a little bit. So I go back into distributions. It's a word that makes you sound drunk. Distribution. Binomial CDF now. So I still have 20 total questions. I still have a 25% chance, a 25% chance of getting it right. And now when I put a 3 in, it's not going to be equals 3, it's going to be less than or equal to 3. That's what binomial CDF means. From 0 up to the number you put in. and hope to God it's, what did we get? 2251. Kick ass. That's 2252. Why is it? Because we rounded these. I like it. Cool. Kick ass. Do you guys see that? Are you with me? So the most I would do, I'd probably actually do like 3 of these. You have to do 3 and then add them. If I say less than or equal to 2, you have to do 2, 1, 0. And then add them together. Kick ass. How are we doing there? Any questions from that bit? So there are a few questions in the homework that have this kind of thing going on. Yes?
So, if you were to give us a problem like this on a test, do you want to see all 4 of those listed out?
Oh yeah, just like this would be beautiful.
Okay.
Well, tears would come. Yeah, you got to show me work, because otherwise I don't know where it came from. All right, so let's go back to this. Has everybody still got this here?
So the at least is going to be the opposite of that. It's going to be 1 minus.
Yeah, if I said, what's the opposite of less than or equal to 3?
Greater than.
Greater than 3, I like it. So you can't include 3 because it's already here. The opposite would be everything that this does not include. So that'd be greater than 3. So if I said I got more than 3 questions right, and this is a really good example. How many ways could you do more than 3 questions right? It could be 4, or 5, or 6, or 7, or freaking 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The opposite of that would be less than or equal to 3, which has how many parts? 4. Do you remember what I said? If the opposite probability has less stuff in it, I'm going to do it that way. So what would the probability x greater than 3 be? 1 minus this. Because that's everything else, right? If I know the probability of one thing, what's probably everything else? 1 minus that. So the calculator is hardwired to always do 0 up. So if you're trying to do greater than something, you have to do 1 minus what the calculator says. Does that make sense? To get the rest of it. So good question, I like it.
So, wouldn't at least be greater than or equal to, though?
What did I say? Well, this would be more than, yeah. Did I say at least? This is more than. Strictly more than 3.
Right.
This is at most 3.
Okay, so what would be at least?
At least would be greater than or equal to, like you said. So if I said at least 3, then the opposite would be less than 3. So I'd only have to do those. Right? If I said, what's probably at least 3? Well, what's the opposite of at least 3? What does that leave out? At least 3 would be what? 3, 4, 5. So what's that leave out? 2, 1, 0. So I'd only have to do those and do 1 minus that. So if I said you have to be at least this tall to ride the ride, if I'm exactly that tall, I get to ride that freaking ride, right? You with me? I like it. Maybe. Okay. So this guy, I think we left off on subsection B of part B. All right. All right. So I kind of spoke about this just a second ago, but this pretty much happens anytime you have the probability I get 0 successes. So kind of get back into this problem. We had 44 people that were picking. The probability one of them smokes is 15.2%. So the probability that they don't smoke is the rest. I like it. And you can't say, well, I smoked some, and then you smoke. So it was a yes or a no. Probably that none of them smoke. So again, how many total people do I have? 44. Oh crap. That's the wrong button, Jeff. Turn the brightness down a bit. Wow. This would be 44. Choose how many?
0.
Choose none of them. And then probability of success was 0.152. How many of those?
0.
None of them. I don't like that thing. Let's see if this one. All right. My lazy pens is right there. So what goes in here?
24.
Yeah, the rest, the probably failure, and then how many of those do I want? 44, the rest of them. So remember what I just said, that's 1, so all I have to put in the calculator is that piece. If you put the whole damn thing in, it'll still come out to the same answer, but it's like putting in there 1 times 1 times 7, and the calculator's like 7. So if you put the whole thing, you're fine. You don't have to. So what do you guys get when you plug in? Let's see if I get the same thing. 848 to the 44th power.
0, 7.
Yeah, dude. So how do you read this? So that's one reason why I put this on there. What does that mean? Good. That little e is times 10 to the. So that just tells you how many times to move the decimal place in which direction. So I want to move the decimal 4 times back. So once around the 7, and then how many zeros?
3.
So you always have one less 0 than this. I don't know if you guys remember good old scientific notation. So this will be 0.00071 if I rounded. Three zeros, and then 7. I made it 7-1. Cool. How are we doing so far? Kind of makes sense because there's a 15% chance somebody smokes. So out of 44 people, I'm going to expect to get somebody that smokes. So the probability that none of them smoke should be pretty small. And that's exactly what we just discovered. Out of any 44 randomly selected people, more than likely at least one of them is going to smoke. And that's the next question really is, well, what's the probability at least one of them smokes? Well, how many ways is there to do at least one? I can do 1 or 2 or 3 or 4 up to 44. So the opposite of at least 1 is none. So it'd be much easier to do 1 minus the opposite because I only have to do one calculation. We already did the probability of none.